Yeah, welcome to Steffley's Academic Training Center. This is chemistry. First part is under radicals. Yeah, so on talk about radical, the definition for radical, you can say radical is a group of atoms which is present in several compounds but incapable of independent existence. So we're saying that a radical is a group of atoms. So these are a group of atoms which is present in several compounds but incapable of independent existence, which means they cannot exist on their own. So the table below shows some examples of radicals and their formula and the valences that they have. So as you can see, we have radical here, the formula and the valence. So you need to know that radicals are not there on the periodic table. So for you to come up with a formula, for you to write a formula for radical, you need to memorize the table of radicals. So for example, the common radicals that you're supposed to know are, so for example, ammonium, this ammonium, so the ammonium, the formula for ammonium is NH4. The chloride, which is same as chlorine, this one, the formula for chloride is Cl, supposed to be capital letter C, then small letter L here, the chloride. So all these, they have got a valence of 1. Then the chlorate is ClO3. Then hydrogen sulfate is HSO4. Hydrogen carbonate is HCO3. Hydroxide is OH. Nitrate is NO3. Nitrite is NO2. This same as nitrogen dioxide, this one. So all these have got a valence of 1. So you need to know the valences. Then the next table with a valence of 2, we have the carbonate, SO3 carbonate, oxide, which is O, sulfite or sulfate, which is SO4, sulfite. So be careful here, this is sulfate, this is sulfite, SO3, then sulfate is SO4. Sulfide is S. So as you can see, all those with S, sulfide, sulfite, including carbonate, they've got a valence of 2. Then the only one with a valence of 3 is phosphate. Phosphate, PO4, the only radical with a valence of 3. So we need to know all these radicals and therefore formulas. So for example, here is example. Write the formula for each of the following compounds. So when writing the formula, we're not supposed to check on the table of the radicals there, because this table needs to be in our head. So you need to know this table very well. So I've covered this part. So example, write the formula for each of the following compounds. Sodium chloride. So we need to know that sodium is from group 1 element from the periodic table. So the symbol for sodium is Na from group 1 from the periodic table. As you can see, sodium here is group 1, which means it has got a valence of 1. So I'll put 1 here. So you write the valence on top of the element or compound. So then the chloride is Cl. So chlorine, which is chloride, is also from group 7 element, and group 7 element. In fact, group 7 is the chlorine here. they gain one electron. So, we talk about a valence. In short, in case we don't know a valence is the number of electron an atom supposed to gain or lose. So, since chlorine is group 7, which means it's supposed to gain one electron. So, that's the valence. So, the valence is the number of electron an atom supposed to gain or lose. So, one here. Then from here now, we swap the valences. So, sodium, the valence for this one comes this side, we put one here. The valence for this sodium comes here, we put one here. So if it's 1, we ignore. So you don't write a 1. So the formula for sodium chloride will be like this. Sodium chloride like this. It's the formula for sodium chloride. Then go to potassium carbonate. So potassium is there on the periodic table, and potassium, when you try to check on the periodic table, it's in group 1. So the symbol for potassium is K with a valence of 1, because potassium is supposed to lose one electron. Then carbonate is a radical. This one is supposed to be memorized. So the formula for carbonate like this, CO3 like this, with a valence of 2 like this. So now you swap the valences. So write potassium here. These 2 will come this side 2. Then carbonate 3 here. So we can't write a 1 here because to look like a 31. So you put brackets like this. So actually this valence 1 comes here. So now we say that 1 is supposed to ignore it. 1 is supposed to ignore it. So we write K2 and carbonate like this. This is a formula for potassium carbonate. Then we go to the next part, which is ammonium carbonate. So the ammonium is a radical, and also the carbonate also is a radical. So the formula for ammonium is like this. 4. So ammonium, it has got a valence of 1. So put 1 on top. Then carbonate again, CO3, with a valence of 2. The valence of 2. Then now you swap the valences. So this valence for carbonate will come for ammonium. So it will be like this. 4 here. Then put my bracket like this. Then the carbonate is going to receive the valence of 1. Now, since I said if it's 1, we're going to ignore it. So we just need to, we can't write 1, you're going to ignore it. It's the formula for ammonium carbonate. Then I go to this aluminium phosphate. So the formula for aluminium is Al, and aluminium is in group 3 of the periodic table, and it has got a valence of 3, supposed to lose 3 electrons. So I'll write 3 here. Then phosphate, the formula is PO4 with a valence of 3. Then now you swap the valences. So aluminium is going to receive this 3. Then phosphate again is going to receive this 3 again. So if the valences are same, you cancel them. So I'm going to cancel. We'll say this and this cancel. So remain with aluminium phosphate like this. This is a formula for aluminium phosphate. Then I'll go to calcium hydrogen carbonate. So the formula for calcium is Ca like this with a valence of 2. Because calcium is from group 2, which means it has got the valence of 2 supposed to lose 2 electrons. Then the formula for hydrogen carbonate, this one is a radical with a valence of 1. Then now we'll swap the valences. So the calcium, we're going to receive this one. Now since I said if it's 1, we are going to ignore it. So we're going to ignore this one, but one's supposed to be here. Then the formula for hydrogen carbonate like this. Then I'll do like this. I'll write 2 here. So I said 1, we ignore it. So we have calcium hydrogen carbonate like this. I put it 2 here. So this is a formula for calcium hydrogen carbonate. So question 2, write the valence for the elements and the radical for each of the following. This is question 2. So they want us to write the valence. So we know that calcium, it has got a valence of 2, so we'll write calcium, valence of 2. Then carbonate also with a valence of 2. So this is a fine answer. Then iron. So be careful on iron. We have got iron 1, iron 2, iron 3, etc. So now, which means the valence for iron, we are going to get from this oxygen, because remember, before writing the formula, the valences were swapped. So which means even here, the valence for iron was 3, and the valence for oxygen was 2. Then nitrogen and hydrogen again here. The valence for nitrogen, it's here, because when writing chemical formula, the valences were swapped. So which is 3 here. And hydrogen, since there's 1 here, so the valence here is 1. Then there's the exercise here. The exercise here. I'm saying that write the valence for the elements and the radicals in each of the following. So they want you to write the valence for the element and their compound or radicals. So aluminum sulfate, ammonium carbonate, and sodium hydrogen sulfate. So you can write the answers and submit for marking. Then question is supposed to be question 2 again. Okay, this one is a part of exercise, but I'm going to do it. I'm going to do it for you. So they're saying that calcium nitrate has the ions. So as you can see, this an ion is a charged particle. So which means calcium it has a charge of 2, which means calcium need to lose 2 electrons. So we write calcium here. It means it has got a valence of 2. So we write 2 here. Then again, nitrate. We know that nitrate with a valence of -1, it means that's supposed to gain 1 electron. So we put the valence of 1 here. Then now, remember I said that when you're writing the chemical formula, we need to swap the valences. So we have calcium here, the valence for nitrate to come here 1, and nitrate here 3. Don't forget I said we'll always write the bracket, then we'll put a 2 here, because when that's set a 2 here, it will be set 1 here, and it will be wrong. Then I said you're supposed to ignore this one, so it will be calcium nitrate like this, and 2 here. It's a formula for calcium nitrate. Then go to the next part, which is equation. So an equation is a chemical sentence which describes what is happening in a chemical reaction. So an equation is a chemical sentence which describes what is happening in a chemical reaction. So an equation can be represented in the form, example, we have A plus B, and these are reactants. Then give us a C and a G. So this plus sign on the left-hand side, it presents that A react with. So this plus means react with. Don't forget A means react with. Then this symbol, it means give a C or to form. So you can say this was to form. So this one is to form. This one plus it means that react with. React with. React with. This one it means and. So the plus sign on the right hand side, it means and. For example, like when A and B react, when A react with B, it will form C and D. So these are products, these are reactants. So now I'm talking about the word equation. A word equation are equations or chemical written in words. So the chemical reaction written in words. For example, we have write down the word equations for each of the following reactions. Include state symbols. So for example, I have magnesium. So I'm going to write magnesium. magnesium is a metal, so it's a solid. React with then plus oxygen, which is a gas, to form magnesium oxide, which is solid. So this is solid, gas, solid. So this is how you're supposed to write the chemical equation. So you just follow the statement here. Magnesium metal, this is magnesium, react with it, so plus oxygen to form magnesium oxide like this. Then question B, hydrogen sulfide. So you write hydrogen sulfide gas, so this is gas, react with, so plus oxygen, okay, to form sulfur solid and water. Water is liquid, so air liquid. So this is the word equation. Then again, that's saying that question C, iron 2 chloride solution. So ion, so you write ion. No, so you need to be careful here. They're saying that iron 2 chloride solution, so which means this is aqueous. This is aqueous, okay, because of this solution. So this is aqueous, okay, and hydrogen gas are produced, which means these are products. When ion, so we say ion now, solid, because it's a metal. Ion reacts with dilute hydrochloric acid. So they say to form what? Ion 2 chloride plus what? And hydrogen. So put hydrogen down here. Then gas here. Okay. Then hydrogen chloride. So ion is a solid. Hydrochloric acid is aqueous. So don't forget, all acid they're aqueous. Aqueous, AQ, aqueous, aqueous. This one is also aqueous here like this. So this is the word equation. So to be ion plus dilute hydrochloric acid give us iron 2 chloride plus hydrogen gas. Then again, question D, are saying that ion solid react with chlorine gas here, give us ion 2 chloride, which is the gas here. Good. So this is the word equation for the reaction. Then go to the next part. Next part. Okay, this is exercise. This exercise for you. They're saying that write down word equation including such symbols for each of the following equations. So have mercury oxide decomposes into mercury and oxygen. Okay. B, hydrogen gas reacts with oxygen gas to form water. Okay. Sodium metal reacts with water to produce a solution of sodium hydroxide and hydrogen gas. The question D, calcium oxide dissolves in water to produce calcium hydroxide solution. So you can solve and submit answers for making. And the next part is chemical equations. So in fact, we're going to do the chemical equations in the next video. Thank you very much.